Okay, so today we are talking about an article that was released in The Guardian today. And in this article, it's actually on the topic of neuroscience. And we're going to be looking at how the brain has five eras. So a very interesting topic, and it's a new article that highlights the different eras that the brain goes through. So when we use this word era, we're talking about a period of time that the brain goes through. So from the early age, your adolescence, to middle age, and then to older age. Here it's stating that adult mode doesn't actually start until early 30s. I was a little bit surprised when I saw this because, yeah, I think when people normally think about becoming an adult, you normally think about turning an adult at 18 years old. I think this will typically be considered the time when you become an adult. And then, yeah, as you turn 19 and 20, you go into the full stage of adulthood. But in most countries, you will legally be considered an adult at the age of 18. So this study suggests that human brain development has four pivotal turning points, and the four turning points are at the ages of 9, 32, 66, and 83. Okay, so this is really looking at the changes that are happening in the brain to try to get us to understand, what's happening to our personalities, what's happening to our behaviors, what's happening to our characteristics. So let's take a look here. So the scientists have identified five major epochs. Okay, so epochs, again, this is just a word similar to era, referring to a period of time more or less when there are notably some significant events that have happened. Yeah. So an epoch is a period of time in your life, just like an era is. These words are very similar and could be interchangeable. Epoch is more formal and scientific, yeah, to use this word here. Um, so yeah, of the human brain development in one of the most comprehensive studies to date of how neural wiring changes from infancy to old age. So here, when we're talking about neural wiring, we're talking about how the brain is actually connected. So they're connected by neurons. So when the author here is referring to neural wiring, the author is referring to how the brain communicates, yeah, through impulses, through neurons, through connections. So the neural wiring is a way to refer to the network in the brain as a whole. Okay. Also, when we use this word infancy, this just refers to the younger period of our lives. Yeah, typically from the age of birth, yeah, to the age of, let's say, yeah, maybe 0 to 3. But this is broken up into different stages as well. You have, when you are a newborn baby, and then you are a toddler, and then you go into this, yeah, early childhood stage of development before you enter school. Okay, the study, based on the brain scans of nearly 4,000 people aged under 1 to 90, so a very wide spectrum here of all ages, for humans, mapped neural connections and how they evolve during our lives. This revealed five broad phases split up by four pivotal turning points in which brain organization moves onto a different trajectory at around the ages of 9, 32, 66, and 83 years. Okay, so I think here we have the word pivotal turning points. So the word pivotal here is mentioning how this turning point is significant. There are many changes happening, some big changes, not just small changes, but changes that are really changing our character, our attitude, our behavior, our outlook, and our perspective in life. So I think that what the author really is trying to capture here is about how these scientists have broken down the eras of our lives, the eras of the mind, especially its changes, yeah, across five broad phases. Okay, so 9, 32, 66, and 83 years. So, well, it's actually saying five here. Oh, sorry, four pivotal turning points, but then there are five broad phases. So I think the author is going to share with us what those five phases are, but there are four pivotal turning points. Okay, so Looking back, many of us feel our lives have been characterized by different phases. It turns out that brains also go through these eras, said Professor Duncan Astle, a researcher in neuroinformatics at Cambridge University and senior author of the study. So, neuroinformatics here being the heart of the topic, and yeah, the researchers and scientists are the ones that have been studying brain chemistry, neuron connection within this topic at Cambridge University. So this study comes from a very prestigious, very top research institution in the world. So yeah, I'm sure they've been working on this for years. We use this phrase looking back. In this case, it means that when we go through our lives, if at any stage we want to kind of review or talk about that stage in general, you can say, looking back on that time, looking back on my 20s, looking back on my 30s. So, looking back is a nice phrase that you can use to capture a specific period of time in your life and to use this to refer back to it. Okay. So, looking back, many of us feel our lives have been characterized by different phases. I think everyone can agree with that. Absolutely. When you are in your 20s compared to your 30s, you're a completely different person. Same as when you're a teenager and you're going through that phase of development. Your brain is still developing up until the age, I think, of 20. It's different for females and males, but your brain is continuing to develop for a much longer time than we had originally thought. And this study is helping us to understand what's actually happening over the period of the duration of our entire lives. So it's very interesting. So next, understanding that the brain's structural journey is not a question of steady progression, but rather one of a few major turning points will help us identify when and how its wiring is vulnerable to disruption. Ooh, this is an interesting point here. So when we're talking about this structural journey, again, it's talking about how the mind is growing and developing over time. And as we experience new things in our lives, of course, this is going to have a big impact on our minds and on our brains. But scientifically speaking, there seems to be a few major turning points. So yeah, when we use this terminology, vulnerable to disruption. So disruption in this case is just talking about how the brain is connected, and over time, when because of age and because of time, our brains are maybe forming different perspectives and different ideas, and it's also maybe connected to genetics and connected to the way that we think. So it's very interesting that yeah, our wiring is vulnerable, and because of neuroplasticity. So neuroplasticity being the ability for the brain to create new neural pathways throughout all of your life. The brain is constantly evolving and changing and developing. So it's a very interesting concept. And yeah, I'm interested to know more. Um, so the childhood period of development was found to occur between birth until the age of 9. Okay, so childhood, the first phase from birth until the age of 9. When it transitions to the adolescent phase, adolescent here just meaning your teenage years, the years between the age of 9 up until, let's say, the age of 18, an era that lasts up until the age of 32. So actually it's saying here that the adolescent phase of the brain itself is up until the age of 32, whereas in society, we'll consider adolescence typically is only the teenage years. So as a person in society, your adolescence is much shorter than the era that it actually lasts up until the age of 32 for your brain itself. So very interesting concept and interesting point. In a person's early 30s, the brain's neural wiring shifts into adult mode, the longest era, lasting more than 3 decades. A third turning point around the age of 66 marks the start of an early aging phase of brain architecture. Finally, the late aging brain takes shape at around 83 years old. Okay, very interesting. So we typically become an adult, speaking specifically about the brain's architecture at the age in your early 30s. And then this pretty much sticks around for 3 decades. So you've got 30 years of that same architecture, that we're referring to here. And then you have a third turning point at around the age of 66, so right into your retirement age. So 66 typically being the age that you can retire, typically for a man. I think maybe for a woman, it's 1 year earlier. And then we go into another phase of the brain architecture. So this is, built with so much experience and maturity and perspective, and it's going into this more late phase, this late aging brain, which takes shape at around 83 years old, which is interesting. So again, you have more or less another 20 years or so, just less, before your brain adapts and evolves again into this other period. But what's actually specifically happening throughout these changes, they haven't gone into detail about that yet. They're just capturing it from this very broad overall perspective. Okay. The scientists quantified brain organization using 12 different measures, including the efficiency of the wiring, how compartmentalized it is, and whether the brain relies heavily on central hubs or has a more diffuse connectivity network. Okay, interesting. So again, using some different tools of measurement, such as quantifying. So to quantify is to figure out the number of something. So trying to figure it out using these 12 different measures. So so these are some of the metrics that they're using to try to define these different eras within the brain. So one of them is efficiency. One of them is how compartmentalized it is. So compartmentalized just means like there's a section of the brain, and that section of the brain will be responsible for different functions such as thinking or reading or speaking. So yeah, and there are these central hubs that the brain relies heavily on, or has a more diffuse connectivity network. So again, it's talking about how the brain connects, how it compartmentalizes, how it is categorized, and they're trying to figure out what are the ways that they can do that. And they figured out that there are maybe 12 different types of measures to help try to identify these neural networks and this brain architecture. Let's read on. So from infancy through childhood, our brains are defined by network consolidation as the wealth of synapses, the connectors between neurons in a baby's brain are whittled down, with the more active ones surviving. During this period, the study found the efficiency of the brain's wiring decreases. Interesting. So when we talk here about the use of the phrasal verb whittled down, it means to break down into its smallest component. Yeah. So we're saying that the connectors between neurons in a baby's brain are whittled down. So typically they are big synapses, big areas of the brain, but because the baby's brain is much smaller, it's whittled down. It means that it's kind of squeezed into a much smaller size. As we get older, the brain gets bigger, and we have more space for it. So yeah, in this case, the brain is developing over time, and yeah, there are more connectors, more neurons, and typically we're getting smarter as we age, as the brain is able to think more logically, and we are able to connect our brain to our emotions, and yeah, go through these different phases of aging. And meanwhile, gray and white matter grow rapidly in volume, so that cortical thickness, the distance between outer gray matter and inner white matter, reaches a peak, and cortical folding, the characteristic ridges on the outer brain, stabilizes. Okay, this is very interesting. So this is even new vocabulary for me. So cortical folding, cortical thickness. So cortical would be some specific aspect of the brain. Let's take a look at what it means specifically. So if the scientists are paying attention to the cortical thickness, then yeah, so this is just referring to the outer layer of the cerebrum. So this is the part of the brain, and the cortical being the outer layer, where you can find gray and white matter. So gray and white matter, again, referring to some very interesting aspects of our brain that will be measured by the scientists to try to figure out what impact this has on our age and what impact it has on us as we grow. The ridges, these are typically, again, small folds in the outer layer of the brain. So a small fold can also be referred to a ridge, like the ridge of a mountain. So ridges is kind of just like a surface, and this surface maybe is lower or higher and it's connected. It can be called a ridge. So let's look at the definition, the dictionary definition of this: a long, narrow hilltop, mountain range, or watershed. So referring specifically to some type of surface, and how that surface is either lower or higher. Okay. In the second epoch of the brain, the adolescence era, white matter continues to grow in volume, so organization of the brain's communications networks is increasingly refined. This era is defined by steadily increasing efficiency of connections across the whole brain, which is related to enhance cognitive performance. The epochs were defined by the brain remaining on a constant trend of development over a sustained period rather than staying in a fixed state throughout. Okay, interesting. So this is going in to talk about the second epoch, where the white matter continues to grow in volume and is increasingly refined. So when we use this word refined, again, it means to re-establish something and make it new. So the definition here is with impurities are unwanted elements having been removed by processing. So that's a very scientific definition. But really what it's saying here is, so organization of the brain's communication networks is increasingly refined. It means, again, something is added, something is new. There's a new layer. It means something is being made more efficient in this process. So in this specific case, it's about increasing the efficiency of the connections across the brain, and this is helping to enhance cognitive performance. Yeah, so it's a very interesting trend of development. I'm going to add the rest of this article into the video, so if you want to continue and read it yourself, you can take a look. And yeah, I hope this was useful for you today, guys, and I will see you on the next one.